So good morning to all of you MSc first year physics student. So today again welcome to lecture series in our subject quantum mechanics, and we want to continue our chapter is angular momentum, and today we want to see the point which is eigenfunctions of the L square, and we want to see that the first method of determining the eigenfunctions of the L square. So first of all, you know that for the spherical harmonics, you know that in terms of this Cartesian, in the Cartesian system, the L square, what is formula, you know that, and in spherical harmonics, this formula, this also we have to know that this formula, which is nothing but the L bar square is equal to minus h cross square in bracket of 1 upon sin theta in bracket sin theta dou by dou theta plus 1 upon sin square theta plus 1 upon sin square theta dou square by dou phi square. Okay, so this formula already you know that. Using of this formula, we want to find out the eigenfunctions of the L square. Okay, so that is to the eigenfunctions for this formula, to the eigenfunctions in terms of y of theta, and this is considered as y of is a function of theta and phi, and this is nothing but 1 upon under root of 2 pi, 1 upon under root of 2 pi capital theta of Lm is a function of small theta and e to the power Im of phi. Because we have to know that the normalization constant of Lz operator, which is nothing but, okay, 1 upon twice under root of twice pi e to the power Im phi, and the eigenfunctions of this equation, okay, which is nothing but the Ylm of is the function of theta and phi, which is derived for this. Okay, so using of these two equations, so this equation gives the next equation, which is L bar square of y Lm of theta and phi. Okay, so that is the multiplication of these two equations. Okay, multiply of this equation, so that is the L square, and multiply this equation by this y Lm of theta phi. So multiplication of this equation is nothing but the minus h cross square divided by this under root of twice pi, under root of twice pi in bracket 1 upon sin theta, 1 upon sin theta in bracket sin theta dou by dou theta plus 1 upon sin square theta dou square by dou phi square. Okay, this bracket complete, and multiply by this RHS side, that is theta, capital theta of Lm of theta e to the power Im phi. So this is nothing but capital theta is the function of L and M of theta e to the power Im phi. Okay, so if we reduce this equation, so the final equation will become here. So this h cross square is as it is, so that is h cross square, and we have to know that the eigenvalue function or eigenvalue of L square, which is nothing but the h cross square L into L plus 1. So this is nothing but the h cross square L into L plus 1. Okay, divide by this under root of twice pi, under root of twice pi into, as it is this function that is horizontal part, so capital theta ln of theta into e to the power im phi. Okay, so after eliminating the phi dependent part, so which after eliminating the phi dependent part, so it reduces to okay. So in this equation we want to eliminating the phi dependent part, so this equation will become here the 1 upon sin theta d d theta in bracket of sin theta d by d theta of the function of this capital theta of Lm is a function of small theta, plus this bracket complete, plus L into L plus 1 minus m square divided by sin square theta in bracket capital theta of Lm of theta, and this equation which is equal to 0. Okay, again see that in this equation after eliminating the phi part of the function, so that is the dou square by dou phi square and e to the power im phi, so this part which is neglected form or eliminating for this function, so this equation reduced to 1 upon sin theta d d theta, sin theta of d d theta is a function of capital theta of Lm of theta, and plus L into L plus 1 minus m square by sin square theta Lm of theta is equal to 0. That is this equation coming after the reducing or eliminating the part of the phi. Okay, so again we want to write here, this equation is known as the Legendre differential equation. Okay, so this equation which is known as the Legendre differential equation. This equation is known as Legendre differential equation. Legendre differential equation. Okay, and it is solution can be expressed, and it is solution can be expressed in terms of associated, in terms of associated Legendre functions. Legendre function, and this function which is nothing but, okay, so this equation which is known as the Legendre differential equation. Legendre differential equation, and this equation which is expressed in terms of the Legendre functions, and this Legendre function which is known as Plm of cos theta. Plm of cos theta. Okay, so if we define this function, so this is known as the capital theta of Lm of theta is equal to some constant value or arbitrary value, that is the C Lm of P Lm of cos theta. Okay, again see that. So this equation, okay, that legendary function which is defined in terms of the some constant value into PLM of this PLM cos theta. Okay, again if we solve this equation, so this equation gives the PL m of x is equal to 1 minus x square whole power mod of capital M divided by 2 into d power of mod M divided by dx power of mod M of PL of x. Okay, so using of this formula we want to get next equation, and after the solution of this equation we have to use the Rodriguez formula of this legendary equation, and we want to solve out the eigenfunctions of the L square. Okay, so see here the next formula of this shows that, okay, for this equation, so this shows that PL of minus M of x is equal to PLM of x. Okay, and this PLM, which is PL of x, is the nth legendary polynomial which is defined in the Rodriguez formula. Okay, so where the PL of x is the nth legendary, legendary polynomial, which shows or which is defined by Rodriguez formula. Which is defined by Rodriguez formula. Okay, and this Rodriguez formula. Okay, so using of this equation, so that is the legendary functions. So this PLM of cos theta, and after this solving of this legendary polynomial, so this PL of minus M of x is equal to PLM of x, and after using of this, so this PL of x is nothing but the nth legendary polynomial, and which is defined by the Rodriguez formula, and this Rodriguez formula which is nothing but the PL of x is equal to 1 upon 2 power L into M factorial into d power L divided by dx power L, okay, into x square minus 1 whole power L, x square whole power L, and using of this formula we have to solving out the differential value. So what is the value of this legendary polynomial? So we want to solve it here. Okay, so for example, if we consider for first legendary polynomial, so that is taking the value is equal to L is equal to 0. Okay, so we can obtain at once first few legendary polynomials. So we can obtain at once first few So for example, so using of this formula, P L of x 1 upon twice power L, L factorial, d power L by d x power L, x square minus 1 whole power L. Okay. So now, first of all, we have to see. Okay, now, put, for example, for L is equal to 0. For L is equal to 0, we want to find out this first polynomial. Okay. So this use the P. Okay. So that is the linear polynomial. For L is equal to 0, so put here L value is 0 of x is equal to 1 upon 2 power 0 into 0 factorial. Okay, d power 1 or d power 0 by dx power 0 into x square minus 1 whole power 0. Okay, and answer which is for this polynomial. Okay, so this is given as 0 factorial is nothing but the 1, 2 power 0 is 1, so 1 by 1 factorial which is nothing but the 1. So that is the value of first polynomial, that is p naught x is equal to 1. Okay, now we want to solve this legendary polynomial taking value L is equal to 1. L is equal to first few polynomial I want to solve here. Other polynomials you will also try to yourself. So for L is equal to 1. Okay. So for L is equal to 1, we want to solve out this legendary polynomial. So that is P, L value is nothing but the 1. So P1 of x is equal to, this is 1 upon 2 power 1 into 1 factorial into d power 1 by dx1, so that is the d dx of x square minus 1 whole power 1. If we solve this legendary polynomial, this 1 upon 2 power 1 is nothing but 2, 1 factorial is 1, and derivative is d dx of x square, that is nothing but the twice x, and derivative of this constant which is nothing but the 0. Okay, so these two get cancelled, these two get also cancelled, so that final answer of this which is nothing but the x. Okay, so for the legendary polynomial p1 of x which is nothing but the x. Okay, again we want to solve this legendary polynomial for L value which is taken as a 2. Okay, for L is equal to 2. L is equal to 2. The legendary polynomial which is considered as P2 of x is equal to 1 upon 2 power L, so that is nothing but the 2 power 2 into 2 factorial into d2 divided by dx square into x square minus 1 whole power 2. Okay, if we solving this polynomial, so this is considered as 1 upon 2 power 2 is nothing but 4 into 2 factorial, that is 2 into 1. So first derivative, so that is the d by dx of d square by dx square, and this is nothing but the x power 4 minus twice x square and again this plus 1. Okay, and if we solve this legendary polynomial, okay, so see here 1 upon 4 into 2 into 1, this is nothing but the 1 by 8 d dx. Okay, taking first derivative of this function which is nothing but the 4x cube minus 4x. Okay, again take differentiation of this function, so this is nothing but the 1 divided by 8 of 12x square minus 4. Okay, and if we differentiation again, no sorry, divide this 12 by 8 and 4 by 8, so this is nothing but the x square. Okay, 4 3 is 12 and 2, that is the 3 by 4. So this is nothing but the 1 by 2 in bracket of 3x square, okay, minus 1. 3x square minus 1. So this is the legendary polynomial for L is equal to 2. So that is the P2 of x. Okay. So this type we solving next for P is equal to L is equal to 3, L is equal to 4. And if we put in this formula, so what is the solution of this legendary polynomial? So first of all we consider, so for L is equal to 3, okay, for L is equal to 3, okay, so we want to express this legendary polynomial for L is equal to 3. So this formula is coming out, okay, P3 of x is equal to 1 upon 2 power L, so that is nothing but the 2 power 3 into 3 factorial into d cube divided by dx cube of x square minus 1 whole power 3. Okay, and if we solving this differentiation and this, so we have to try your oneself. So the final answer of this legendary polynomial, so that is the P3 of x is nothing but the 1 upon 48. Okay, so 1 upon 48 into d cube by dx square, x square minus 1 cube, and final answer of this legendary polynomial but the 1 by 2 5x cube minus 3x. Okay, if we solving this mathematical algebra, so this polynomial which is nothing but the 5x cube minus 3x minus 3x. So this is the legendary polynomial function or solving of legendary polynomial for L is equal to 3. Now we want to solve out this legendary polynomial for P4 of x. Okay, that is the L value for. Okay, for L is equal to 4. So this legendary polynomial expression, which is nothing but the P4 of x is equal to 1 upon 2 power 4 into 4 factorial into d power 4 by dx 4 power 4 into x square minus 1 whole power 4. Okay, and 2 power 4 we have to know that is the 16 value into 4 factorial, and if we solve this legendary polynomial, so that answer will become 1 by 8 in bracket of 35 x power 4 x power 4 minus 30x square plus 3 and again we want to that number of you have to taken the different value of the L, so we have to call number of polynomial or legendary polynomial. So next value for we want to taken for L is equal to 5. This legendary polynomial is nothing but the P5 of x is equal to 1 upon 2 power of 5 into 5 factorial. Okay, d power 5 by dx power 5 into x square minus 1 whole power 5. And if we solve this legendary polynomial, the answer which is coming 1 by 8 63x power 5 minus 70x cube plus 50x. So this answer, if we solve this differentiation, okay, then you will be get this answer, okay, and this numerical factor for solving of this, okay. So this is the legendary polynomial which is satisfy the following closure or completeness relation. And which relation? So that the legendary polynomials, the legendary polynomials, satisfy the following closure or the following closure or completeness relation. And this is nothing but 1 by 2 summation over L is equal to 0 to infinity, and this relation which will become here twice L plus 1, into PL of x power 1 into PLX is equal to delta of x minus x prime. Okay, so up to this, this relation which is nothing but the legendary polynomial which satisfy the closure or completeness relation, and this relation which is given here. Okay, up to this we want to see the algebraical part of this eigenfunction of L square by defining the legendary polynomial and using of this legendary polynomial function PLM of cos theta. Okay, and after that solving of this legendary polynomial will be get here, that is the Rodriguez formula, and this Rodriguez formula using of this we have to express different legendary polynomials for different L values. Up to next lecture we want to see again next mathematical calculation, what is the result of this legendary polynomial which is comes out, so that will be seen in the next lecture. So thanking of you.